Hey guys, welcome again. In this section, we would be talking about replica sets. So let me quickly walk you through a brief history, which I already did, but let me reiterate. Replica set is the next generation replication controller. The only difference between replica set and replication controller right now is the selector support. Replica set supports the new set based selector requirement, as we already discussed, whereas the replication controller only supports equality based selector requirements. Now, how to use a replica set? Now, most Kubernetes-1 commands that support replication controller also support replica sets. One exception is the rolling update command. If you want the rolling update functionality, please consider using deployment instead. Also, the rolling update command is imperative, whereas deployments are declarative. So, we recommend using deployments through rollout command. While replica set can be used independently, today it's mainly used by deployments as a mechanism to orchestrate pod creation, deletion, and updates. When you use deployment, you don't have to worry about managing the replica sets that they create. Deployments own and manage their replica sets. When to use a replica set? A replica set ensures that a specific number of pod replicas are running at any given time. However, a deployment is a higher level concept that manages replica sets and provides declarative updates to pods along with a lot of other useful features. Therefore, we recommend using deployments instead of directly using replica sets. Unless you require custom update orchestration or don't require updates at all. This actually means that you may never need to manipulate replica set object. Use a deployment instead and define your application in the spec section. Now let's quickly move to one of the examples which illustrates the details which we just discussed, and you can see that on the screen. Now, saving this manifest into frontend.yam1 and submitting it to Kubernetes cluster should create the defined replica set and the pods that it manages. As you can see on the screen. So now writing a replica set spec. As with all other Kubernetes API objects, a replica set needs the API version, kind, and metadata fields for general information about working with manifest. We will be discussing it as we go forward, but for now, just hold on for a while. A replica set also needs .spec section. Now, coming on to pod templates. So, the .spec template is the only required field of .spec. The .spec template is a pod template. It has exactly the same schema as a pod except that it is nested and does not have a API version or kind. In addition to required fields of a pod template in a replica set must specify appropriate labels and an appropriate restart policy. For labels, make sure to not overlap with other controller. For restart policy, the only allowed value of .spec, .template, .spec, .restart policy is always, which is the default. For local container restarts, replica set delegates to an agent on the node, for example the kubelet or Docker. Now coming on to pod selector. The .spec selector field is a label selector. A replica set manages all the pods with labels that match the selector. It does not distinguish between pods that it created or deleted and pods that another person or process created or deleted. This allows the replica set to be replaced without affecting the running pods. The .spec, .template, .metadata, .labels must match the .spec.selector or it will be rejected by the API. In Kubernetes 1.9, the API version apps\v1 on the replica set kind is the current version and is enabled by default. The API version apps\v1 beta 2 is deprecated. Also, you should not normally create any pods whose labels match this selector either directly with another replica set or with another controller such as deployment. If you do so, the replica set thinks that it created the other pods. So if you do end up with multiple controllers that have overlapping selectors, you will have to manage the deletion yourself. Now coming on to labels on the replica set. Now the replica set can itself have labels, which is .metadata.labels. Typically you would set these the same as the .spec.template.metadata.labels. However, they are allowed to be different and the .metadata.labels do not affect the behavior of the replica set. Coming on to replicas. You can specify how many pods should run concurrently by setting .spec.replicas. The number running at any time may be higher or lower, such as if the replicas was just increase or decrease, or if a pod is gracefully shut down and a replacement starts early. If you do not specify .spec.replicas, then it defaults to 1. Now let's quickly move to how to work with replica sets. To delete a replica set and all its pods, use Kubernetes-1 delete. The Kubernetes will scale the replica set to 0 and wait for it to delete each pod before deleting the replica set itself. If this Kubernetes command is interrupted, it can be restarted. When using the REST API or Go client library, you need to do the steps explicitly. So you can delete a replica set without affecting any of its pods using Kubernetes-1 delete with the -cascade is equal to false option. When using the REST API or Go client library, simply delete the replica set objects. Once the original is deleted, you can create a new replica set to replace it. As long as the old and new .spec.selector are the same, then the new one will adopt the old pods. However, it will not make any effort to make existing pods match a new, different pod template. To update pods to a new spec in a controlled way, use a rolling update. Now let's talk about isolating pods from a replica set. Pods may be removed from replica set target set by changing their labels. This technique may be used to remove pods from services for debugging, data recovery, etc. Pods that are removed in this way will be replaced automatically, assuming that the number of replica is not also changed. Okay, now coming on to scaling a replica set. A replica set can be easily scaled up or down by simply updating the .spec.replicas field. The replica set controller ensures that a desired number of pods with a matching label selector are available and operational. So I'm taking a pause here in this lecture, and then I would be starting afresh and we would be talking a bit more about replica set. like replica set as an horizontal pod auto scalar targets and so on. Thank you.